Good morning, everyone. Can you believe it? It is Monday, May 18th, and this is the last day, not the last day, it's the last week of new lessons. 3 lessons left in science class. Yes, the following week after Memorial Day, I'll be available to help you if you need it, but we're down to 3 lessons. It doesn't really feel like the end of the school year, but of course, nothing really feels like it should this time of year. So we'll just do the best we can and learn as much as we can before our time together is over. All right. So this week, we're going to have a couple of lessons on stars. Today, stars and galaxies. Tomorrow, we'll talk specifically about the sun. And Wednesday, I think I'm just going to talk to you, all of you, about stuff, about life, and probably not so much about science stuff. All right, so that's the plan for the week. There will be, of course, a couple of short quizzes to take so that I can keep track of your attendance and whether or not you're following along with my teaching for the week. So here we go. Stars and galaxies. Of course, this document has already been shared with you, the chapter, so please follow along with me and you can use it as a resource to help you as well. So when we start here in this first section about stars, it talks about constellations. And constellations are patterns of stars in the night sky. And when we look up and see those constellations, some of them, make pretty good sense to us, like the Big Dipper. Raise your hand if you can find the Big Dipper. Yeah, some of you can. There are others that maybe you can find as well. Orion is pretty noticeable if you know what to look for, and there are some others. But basically, it's a collection of stars that the ancient Greeks and Romans and other early cultures, they looked up and saw them and they said, hey, that looks like a horse, so let's call that Pegasus, or that looks like whatever. All right, those are constellations, just stars that make up patterns in the sky. And if you look at this picture, the tricky thing about constellations and stars is that it's hard to get a sense of distance. It appears to us that all the stars are about the same distance away from us, like on a globe or a sheet around the Earth. All right. In fact, that's what early people thought, that the stars were kind of pinned to some surface around the Earth, and they're all the same distance away from us. That's not true at all. Stars can be vast distances away from the Earth. Um, and when we look up and see them, their brightness depends on lots of things, but one of the things it depends upon is its distance away from us. If you look here, these are the stars of Orion as we look from Earth, and it's, these 3 on his belt are typically the easiest to find, but you can follow them through and see which specific stars make up the constellation Orion, and you can see that they are nowhere near each other, right? They are vast distances away from each other. But to us, they look like they're all in nice order to make up that constellation. All right. For us, many of the constellations appear to rotate around Polaris, or the North Star. Maybe you've heard of the North Star. It was used to navigate in early times and probably still can be. The neat thing about the North Star is that it's pretty much directly above our North Pole. And so the further north you go in latitude, the higher in the sky it is, until you get to the North Pole and it's straight above you. All right, you get to the equator and it's going to be all the way down at the horizon. You probably wouldn't even be able to see it. All right, so the North Pole, or the North Star, I want to just show you a couple of things. Now, credit can go to these websites that I'm using to show you, but this is the Big Dipper. All right, and you can use the Big Dipper to find the North Star. You find the end of the dipper right here. Dipper like it dips water kind of thing, right? You find the end of it, and the bottom up to the top edge, this front edge of the dipper, you follow this line straight up in this direction. And when you do that, and I'm going to show you this different picture right here, it's going to open. There it is. Here's the Big Dipper, and we follow the front edge straight up, and it takes us to Polaris, or the North Star, which is right there. In this picture, it looks like the North Star is like super bright or like it's going to stand out. In honesty, it's super bright. It's nothing special when you compare it to other stars in the night sky, other than it is very specific as to its location. It is always, for us, it's about 43 degrees above the horizon. You get, measure 43 degrees, you look to the north, there it is. All right. So that's Polaris, that's the North Star. Hopefully someday you'll find that on your own. And you'll show me that, you learned something, which would be kind of cool. There are 88 modern constellations. I'm not going to bore you with necessarily learning them. You just need to know that they are made up of stars of varying distances. And from our perspective here on Earth, they create shapes that people gave names to. All right. We're going to move on and talk about the brightness of stars, and that's measured in something called magnitude. How bright it is measured in magnitude, and there's two types of magnitude, and it's important to understand the difference. The first I want to talk about is not first in the order here. I want to talk about the second one, apparent magnitude. Apparent magnitude is the measure of the amount of light received on Earth. Let me put that in English. It's how bright it looks to us. That's apparent magnitude. Like, apparently it's really bright, or apparently it's really dim. All right. When you look in the direction of the sun, because you never want to look directly at it, when you look in the direction of the sun, it appears to be very, very bright to us on Earth, which it is. Now, if we compare the sun to other stars and we use the absolute magnitude is a measure of the amount of light it gives off, which means that's kind of its real brightness. The absolute magnitude is the real brightness of the star, regardless of how close we are to it. All right? So kind of like if we lined up all the stars and they were all the same distance away from us, which one shines the brightest? That's got the highest absolute magnitude. All right. So that's a huge difference. How bright does it appear to be is the apparent magnitude, and how bright is it really? That's the absolute magnitude. All right. And those are definitely going to be on the quiz, so hopefully you're paying attention to that. Now, how do we measure things in space? Things in space are huge distances. In fact, they're typically measured in something called a light year, which is the distance that light travels in 1 year. Light year sounds like time because it has the word year in it. It's not time, it's distance. How far does light travel in 1 year is 1 light year? 9.5 trillion kilometers. 9.5 trillion kilometers away. A long way away. That's 1 light year. Remember, light travels about 300,000 kilometers per second. That's very fast. All right. And you do that for a year, you get out a long ways. All right. So, some examples here. It talks about Proxima Centauri is 4.3 light years away. That's 40 trillion kilometers. Okay. But how do we actually measure the distance? And this is kind of a cool little thumb exercise. Again, I think we did one where I covered up my whole head with my little thumb, right? This is really hard. There you go. But we can use that as a way to replicate parallax. Parallax is determined by observing the same star when Earth is at two different points in its orbit around the sun. So you look at the star, compare it to the background stars, let's say in summer when we're on one side of the sun, and then you look at the same star and compare it to the background, maybe in winter when we're on the other side of the sun. And what we do then is you measure how much does it appear that the star has changed compared to its background based on our change in orbit. All right, let's try this. All right, find something that's like across the room. All right, close one eye, hold your thumb up to it. Then open that eye and close the other one. You can see that your thumb appears to move a certain distance. Now, if you pick an object further away and you do the same thing, it's going to appear that your thumb has moved quite a bit further. And so when we look at that, the further that it appears that the star has moved according to its background, the further away it is from Earth. And that's how scientists use parallax to figure out the distance of a star from the Earth. Last thing for the day, properties of stars. Let's talk a little bit about color and how color relates to temperature. The color of stars. Take a look at this. Up here we got the indigos and violets all the way up to the reds over here. So which end of that spectrum would you think are the hottest stars? Red or blue? I have no idea if you got it right or wrong. I know it doesn't make sense when I think about how my hot and cold water are marked, right? The honest answer is the warmest stars, the hottest stars, are bluish white. They're on the left, the blue-white end of the spectrum. The coolest stars, the coldest stars, which is still not very cold, but the coolest stars are actually the reds. So when we look at temperatures of objects, of things, blue is hot, red is cold. I don't know how we got our labeling on our faucets and those kinds of things. Doesn't really make sense. The Earth is right over here in the yellow. I'm sorry, the sun is right over here in the yellow. And here's what you need to understand about the sun, which I'm going to fill you in more on tomorrow. It's average. It's not hot, it's not cold, it's not big, it's not small. It's just really close to us, and it gives us everything we need to live. All right. So that is your introduction to stars and constellations. We learned about the different shapes that are formed by the stars in the night sky. We learned about Polaris, or the North Star, how we might be able to find that. We learned about a light year and that it's a measure of distance. We figured out how to use parallax with our thumb and how an object changes over time or from different perspectives. So we learned a lot about the introduction here. Absolute magnitude is just actually how bright a star is, and apparent magnitude is how bright it appears to be. All right. All of those things are going to be on the quiz. I hope you were paying attention. I kept it under 14 minutes. All right. So do your best. I want you to do your best on the last couple of assessments that we have. Do your best on the quiz today. If you need my help, email bswitz@nfdlschools.org. Send me a message on Google Hangouts, request a Google meeting, and I am here to help you. All right. So with that said, I will see you again tomorrow, and we will talk specifically about our sun. So with that, I want you to have a great day, and I will talk to you tomorrow.